Okay, this question is called a simultaneous question, simultaneous equations, and it says solve the simultaneous equations. And what they do is they give you an equation like this, which we know is a line, 3x minus y equals 4. That's a line. And this is some other kind of function. We don't know exactly what it is, but we want to find out the points that will satisfy the x and y coordinates that will work in both. Well, there's a way of doing this, and the first step is really pretty easy. What you do is you just make this 3x minus y, you make y the subject. Get y by itself. So we add y and we subtract 4. So this is 3x minus 4 equals y. Y equals 3x minus 4. That's all they did. Add y to both sides, and so you'll have a y all by itself, and subtract 4 from both sides. Now that's a key thing. We've got y equals. You might try and get x equals, but we don't like fractions so much. So y equals 3x minus 4 is really good. And what we do with that y equals 3x minus 4 is because y equals 3x minus 4, we can go over here, look right there, look where that y is. We can rub out the y, imagine a bracket being there, and instead put in 3x minus 4. It's called substitution. And then we do it again right here. Instead of that y right there, we put 3x minus 4. Well, then we get a mark for making y the subject, y equals, and then we get another mark for substitution. Okay, now we've got to do some algebra. Now this is a little bit tricky. You have to work out 3x minus 4, what it equals. You do FOIL on it and work it all out. It turns out that it's 9x squared. It's going to be minus 24x, and it's going to be plus 16. But hey, there's a negative in front of here. You could think about it as negative 1, and it's going to get multiplied by all those things. So it's going to become minus 9x squared. The minus 24x that you get out of this is going to get multiplied by negative 1 and become plus 24x. And the plus 16, remember, just go 3x minus 4 and multiply it out carefully and do FOIL on it to make sure you get it right. That plus 16 is going to turn into minus 16. Well, here we go. 2x times 3x is 6x squared. We have 2x times minus 4 is minus 8x. You're going to have minus 16 here. Looks like Mr. Autry added this minus 2 and got a plus 2 here now. Well, all we're going to do is put the x squareds together. Let's see what we get here. We have 1x squared plus 6x squared. That's 7x squared. Take away 9x squared. 7 minus 9, that's minus 2x squared. There's the x squareds all done. Well, here we have 24x. When we take away 8x, that's going to be plus 16x. Here we have minus 16 plus 2. That's minus 14. Now, you look at this thing here and you see that 2 goes into everything. And it's way nicer to have a positive number as the leading coefficient. So if we divide everything by 2, or even better, divide everything by negative 2, this question is going to get a lot simpler. Negative 2 divided by negative 2 is 1x squared. 16 divided by negative 2 is minus 8x. Negative 14 divided by negative 2 is plus 7. Now you just put 2 brackets down. X times x is x squared. Now you're looking for 2 numbers that multiply to equal positive 7, but somehow combine to equal minus 8. Well, minus 7 times minus 1, there's not many things that multiply to equal 7. So if it's going to factor, it's going to be 7 and 1. Oh, that's right, minus 7x minus 1x. That's the outside and the inside. Hey, this works out perfect. It's x minus 7 times x minus 1. Do your FOIL on it, you'll see that you get this. Now you could use the quadratic formula, but you don't want to. You'd get 2 answers here. X is 7 and x is 1. But gee, how do you figure out what y is? Well, all you do is take this 7 and put it back in here for what x is. So you go 3 times 7, that's 21, minus 4. Oh, that's how Mr. Autry got 17. He just took that 7 and put it back in here. Let's do the same thing with the 1. We're going to go way up here. We're going to put it right in there. 3 times 1 is 3. 3 minus 4 is negative 1. So there's your solutions. X equals 7, y equals 17, and x equals 1, and y equals minus 1. Those are the ordered pairs that work in both relations, okay, but in both equations, and that's called the solution. So I hope that helps.